So we're reviewing for summative number 11, fall 2019. And I will work on whatever you guys need me to work on. The first question is, can you graph two lines and tell me the solution as to where they intersect? And you got to write it as an ordered pair. So, can we skip this one? Okay. The next one is a linear inequality, which is a little more involved because you got to worry about solid lines and dashed lines and where to shade and all that. Turns out this question actually is not on this part of the test. We didn't want to we needed to shorten the test, essentially, is what the issue was. So later on the test, when you get to the linear optimization questions, we have you do the same thing here where you have to create a feasible region. So with that in mind, we kind of just took this question off of the test totally. So you're not going to see one of these on the first section. Okay? I still think you should practice it.
Have we done one of those?
Yeah. Before Thanksgiving.
I don't remember.
I think this question is not on the test. You still have to do this concept later on the test, but there's not like a separate please graph a feasible region in the section 1. I love hearing that.
So I'm just curious.
You solve for y. You graph the line.
Yeah.
You make it solid or dashed.
Yep.
And you either shade above or below the line, and then you only shade where they intersect.
Right.
Right.
But you don't take into account because it's dashed, that means that whatever's on that line.
The boundary line itself doesn't include a solution. That's exactly right.
And so does that mean you can't use those intersection points?
So you're talking about story problems from yesterday? Because that wouldn't happen in a story problem. Because it would say you have up to $200 to spend. So that means you can spend $200. Right? Yeah. So we wouldn't have a dashed line issue on the optimization questions. But on these, where there's no context, all the solutions would be anything that's shaded. And then on the solid lines, all the boundaries there would work. The dashed lines would not. Yes. All right. This one is, you must show work. You must do it through elimination, okay? I know matrices are where it's at and all that, but you still got to be able to do Algebra 1 stuff too. Okay? So you must show me elimination. Can we skip that one, though? I mean, I can do it if you want, but it's where you knock out the x's, multiply by something. Who would you like to knock out on that one in particular, by the way, x's or y's? And it doesn't matter. I actually would go with y's.
What?
You don't have to mess with signs, which is usually where kids get mistakes. So it's up to you, though. All right, 4 I definitely want to look at, though, because it looks so like it's not going to be a problem, and then turns out it's a big problem. So Shayla, she's selling bows and bracelets. And she's charging $4 per bow and $5 per bracelet. So the first day she collected $100. There's another clue out here that says she sold 5 times as many bows as bracelets. I would like you to star that statement. That is one of those nasty backwards, you're probably going to mess it up if you're not careful statements.
Kind of like the one from that one day.
Yeah, yes. My arch nemesis. Okay, so the reason I knew this was a nasty one is because as I read it, she sold 5 times as many bows as bracelet. It does not say things like the number of bracelets is, or the number of bows is. So it's not a simple, translate it and walk away kind of a statement. So this one you have to think backwards for dyslexic. That's a good time. We'll talk about that one in a minute. First, let's define our variables. What would you like x and y to represent?
X is bow.
More specific. There we go. Number of bows is fine.
Y is number.
That works. If you decided to switch that around, that's on you. Just make sure your work matches. So the equations, all the money clues are going to go together. If she charges $4 per bow and $5 per bracelet and collected a total of $100, that would look like this. 4x plus 5y equals 100. All right, let's talk about this equation that everyone's going to mess up unless they're careful. She sold 5 times as many bows as bracelets. So when kids are not being careful, they look at that and they just start robotically translating things. So they say things like 5 bows equals bracelet. And that is really wrong. So she sold 5 times as many bows as bracelets indicates that she sold more bows, right? So in order for this statement to work like a scale, a balanced equation, she would have to multiply the number of bracelets by 5 to equal the number of bows. So it is x equals 5y is what we have to translate that to. That is a tricky little question. Now, here's the good news. we're going to get to the end of this question, and we have the luxury of it having context, so we can go back and make sure that our answer makes sense. Like if we end up with an answer where you have more bracelets than bows, that contradicts the whole statement that they had at the beginning of the question. So you just have to kind of make sure that you don't fall for that trick. There will be one of these on your test. It's in this section, in fact. I think it's about cookies or something. I don't know. Cakes? Cookies? I don't know. We're not very creative in these story problems. My apologies. There's one about ducks and geese or something. Pigs and geese coming up. It's a good time. All right, so we're going to need to solve this system. I would suggest substitution. It's really ready for substitution, right? We can just plug that in for x. So my math would come out to this. 4 times, instead of x, we're going to use the 5y. Plus 5y equals 100. What's your problem? Why am I using substitution?
No.
Oh. Oh, yeah. I thought you were complaining about my method of choice, and I was like, back off. Okay, so y equals 4. I agree. So now go back. You got a recipe for x. 5 times 4 means x equals 20. Now, this is not a sentence, so write me a sentence. Shayla sold 20 bows and 4 bracelets. Does that work for the clues that they gave me? Good. Is it 5 times as many bows as she did bracelets? Yes. So I can walk away from that question going, yes, I did that right. That was the tricky one. All right. Any questions on that one? Hi. Oh, before you leave, this is the post-test review. So the schedule of events is on Monday. We're going to review for part 1 of the post-test. That would be all the questions that are circled. Part 2 would be the stuff with the 2s next to them. Okay, you'll notice the whole back is what we're about to do. So that should be a nice, easy day, huh? So post-test is on Tuesday and Thursday next week. All right, I think we need to practice this one. It's a substitution question because that's the only method you guys are going to be able to use on this one. So I look at that second equation, the simpler one, and we can solve for x or for y. But actually, I think you might want to consider your next step in your work. Which one would you like to solve for? Which one do you think would be better to be plugging into the other equation? X would be much simpler work. I mean, it's kind of potato. At some point, you're going to have a quadratic regardless, but if you plug in a y statement, you're going to have to like distribute, FOIL, it's going to be a hot mess, right? So let's call this x equals 2 minus y, if you subtract the y over. And that means any place I see on x in the other equation, which is just right there, I'm going to replace that with 2 minus y. So, this question, guys, do me a favor. Go slow on this question. Because what happens is kids spend 20 minutes on this one question because they keep making like a dumb algebra mistake and they can't catch it. And you've wasted like a ton of time on it, and it's just not worth it. So if you go through it once and you end up with something that you know isn't right, like you get a quadratic that you can't factor, if you can't see your mistake real quick, just move on and do the rest of the test and come back to this question. All right, so right here, now that I've said that, I probably cursed myself to making a dumb mistake. We're plugging that in for x. All right, here goes. You do have some distribution right here. You got a negative 12 that you're distributing. So we do definitely have a quadratic. These usually end up being quadratics. This is a minus 24 plus a 12y. Plus 3y plus 24. Now, this quadratic, definitely not ready for me to consider how to solve it yet. It is not even simplified. So first thing I'd do is I'd maybe group some like terms. We got some like terms here, and then the 24s just end up canceling each other out. So our quadratic is a negative 3y squared plus 15y, no constant, equals 0. So you have a lot of options for solving this quadratic. Most people want to factor it, and this is a good candidate for factoring. And instead of trying to like, oh, I could divide everything by negative 3, which is true, you could. You cannot divide by the y. So let's just go ahead and factor it. What would you factor out of this? Can I also take the negative 3 with it? Be okay if I do that? I mean, if you hadn't divided by a negative 3, this might be a good time to at least remove it from the problem. If you didn't, it's okay. You're still going to get the right answer. You at least have to factor the variable out. Yeah. So this ends up being, let's see, a y minus 5 inside. So you got two factors. If you were to set each of them equal to 0, this guy gives you a really boring statement of y equals 0. This guy gives you a solution of 5. You just got two possible solutions for y. This is where kids get into trouble because they're so excited they got good answers and they throw them down oddly. You have two separate ordered pairs as solutions. Which part of your ordered pair is the y? It's the second part of the ordered pair. So one of your solutions has y equals 0, and the other solution has y equals 5. Now to go find their corresponding x's, well, that's actually very easy because we substituted. Remember, you have a recipe for x right here. It says take 2 and subtract y. So 2 minus 0 would be 2, and 2 minus 5 would be negative 3. So there are your two solutions, and you need to show me both. So if you get down to that stage where you're trying to solve and it's a quadratic, if your quadratic is a hot mess and you can't factor it, you need to just decide to move on from that problem if you can't find the quick mistake. Okay? So then we move on to matrix land, which I know we haven't been there very long, but I think you'll find this might be the easiest part of your whole test. Okay? Do you know how to determine whether you can even multiply them together or not? So I'm just going to make up some examples, not actual matrices, but the dimensions. So if you have matrix A and it's a 3 by 4, and you have matrix B and it's a 2 by 3, can you multiply them together? Okay, so the quick answer is no, because these inside dimensions don't match. So what if you have a matrix 3 by 4, and you're multiplying it by matrix B, which is a 4 by 2? Okay, so that one's a yes, because the inside dimensions match. So that's a yes. And then, say again, Adam, the dimensions of the resulting matrix are a 3 by 2. So there's going to be a question on your test that asks about, here's two matrices. I actually give you two actual matrices, and I say, can you multiply them together? So you do a little dimension check. The answer is probably going to be yes, right? Because then the follow-up question says, if possible, please state the dimensions. It's possible there's one that's a no. I mean, if you're like darn sure, I guess I should probably check the test versions before I make that statement. But now that you know how to check, you should be okay. All right. Oh my goodness. I don't know why kids get so confused on this one. So we have an inventory of textbooks at Harlem that is already here. A truck comes by and drops off a whole other set of books. And they want to know, how many books do we have right now at Harlem? What do they want you to do with these matrices? Just add them together. Just add them. Okay? Because existing plus new guys, right? So the inventory, the updated inventory would just be when you guys add them together. I would not go to the effort of typing this into my calculator and calling it matrix A and B and adding them together. I feel like that is overkill. I think y'all can just add numbers together just fine. So we got like a 30 and a, now that I say this, I'm probably going to mess it up. 49, 72, and a 68. How'd I do? Don't patronize me. Make sure I did it right. I've already caught like 3 mistakes today on my key. I had to delete the key so I could fix it. You believe me? You should not believe my adding skills. All right, this question. Oh, goodness. This is another good case of, it's an application question. So when you get your answer, you should stop and think about your answer. So this is not true, by the way. We're going to take your summative scores and we're going to boost them all by 3%. So rather than hand calculating that for each kid, I could set up a matrix program where it just commands it, like an equation almost, to multiply everything by a certain scalar factor that increases everybody's percent by 3. So you're going to take okay, here's what happens. Kids go, oh, I'm going to use 0.03 because that's 3%. What did they just do to everyone's score? Go ahead and type 74 times 0.03. What do you get? 2.2 or something? Okay, so you just gave that kid who got a 74% on the test, now he has a 2.2%. No, but that's the next thing that happens with kids is then they divide by 0.03 and they get something else. What happens is you want to keep their existing percentage. So you want to keep 100% of it, and you want to increase their percentage by 3. So you're really giving them, 103%. So that scalar factor would look like this. So this works when you're trying to increase a price. This is how they do sales tax. They take 100% of your subtotal, and then they increase it by the percentage of whatever the sales tax is. So like the computer, when it adds in sales tax, will multiply your subtotal by 1.0825 or whatever your tax rate is. Now this works the same for discounts, but what's the difference if it's a discount? Like if it's a sale or something, they would subtract it from 100%. So like we do this at Kohl's all the time, you know, something's 20% off. I don't do 20% of that topic and then subtract it. I multiply it by 8 because I'm really keeping 80% of it. Okay? So keep that in mind. Now we're going to get some more feasible answers, guys. If you multiply all of these, and you don't have to do this as a matrix on your calculator. It's only 4 values, so you can just hand calculate everything multiplied by 1.03. I think you get a 76.22. Does that sound like a more appropriate boost in that kid's score? Okay, that makes more sense. 90.64, a 65.92, and a 97.85. That makes more sense. Now, the question on the test, I believe, at least on one of the versions, it's about money. So where would be an appropriate rounding place for money? The 100th spot, yeah. If the answer is like 1.035789, like don't write that down. Right? Write down the decimal rounded to the 100th spot. This question. Can you do this on the calculator? Yes. No. You got algebra. So you would have to take the rows of your first of all, can you multiply them? I should have checked that. 2 by 2 by 2 by 2. So yeah. And the result's going to also be a 2 by 2. So you take the rows of the first matrix, and then you multiply it by the columns of the second matrix, and you just got to be careful where you're placing what value. So it's a series of multiplications, and then you're adding all your answers together. So we have 24 plus 0, so that first 1, 1 position is a 24. Now, first row, second column is a 6a plus 0, so that's a 6a. Now, the second row times the first column would be a 4c plus negative 16. So can I just call that 4c minus 16? And then second row, second column would be an ac plus 72. What a good time. So we can't do that one on the calculator, so make sure if you run into those 2 by 2s, you know how to manually multiply them together. Okay, this question. Sometimes kids get a little creative, and I kind of wish they didn't. So they know they're supposed to do matrices on their calculator. And what some kids run into is they don't enter the matrices in a proper notation or a proper dimension order, and then they haven't set it up in a right way so they can actually multiply them together. So let's talk about what we're trying to do here. We have the dollar amount for each type of calculator given in this matrix. And then we have how many of each of those calculators are at each of the stores. So I need this data all to kind of stay together. So I need these to stay in terms of columns. And I need this to stay as a row. So I'm going to call this matrix A. And I'm going to call this matrix B. And let's make sure that we can actually multiply these together. So this guy is a 1 by 3, matrix A. Matrix B is a 3 by 3. So can we multiply those together? And the result is going to be a 1 by 3. So when this pops out of my calculator, it's going to be one of these. We'll interpret the results in a minute. Okay? So go ahead and take the time to enter this into your calculator. Please create a 1 by 3 matrix A and a 3 by 3 matrix B. I'm going to pause the video. Viewers, pause and start entering as well. So after multiplying A times B, this is what I got, but you guys tell me if this is not what you got. I got 1151, 2462, and a 14. Ooh, 14. Bless. So we all got the same matrix as a result. That's great, but now we got to interpret that result. So think about what we did. We took the dollar amount for each of the calculators and we multiplied it by store A's inventory. So what we just found in this 1, 1 position is how much money worth of calculator you have at store A. So then this one must be the same thing but for store B, and this is for store C. So just making sure that you know how to interpret that result is kind of the challenge on that question as well. So store A has a total inventory of calculators of 1,151. Store B is 2462. Oops, that's ugly. And source C is 1, 4, 1, 4. The issue that kids run into on that question, for me in the past at least, is they decide to enter the calculator type 1 as their first matrix, and then, this blue guy, as their first matrix, and then the retail value as their second matrix. But that doesn't work the way it's set up right now, so they'd have to like invert one of the matrices in order for that to work. I don't think that's a good idea. Okay, so maybe just don't get creative on that question is my advice to you. All right, everybody's favorite. Now, please don't be afraid of these questions, guys. I'm not asking you to do much. All I want you to do is write this in augmented matrix form. And we were so nice. We even tried to space it out for you, so you could recognize when there's some zeros that you need to incorporate into your matrix. So you don't even have to perform RREF. I don't want the answer. And probably we made this up and the answer is probably horrible. So just be careful with your coefficients. So we got a 2, a -1, but notice you have 0 z's, and then a 5w, and a -1 solution. Now notice it said that could be. The reason we have to be careful about our language is if someone decides like, no, I don't like the order X, Y, Z, W. If they want to rearrange the order, they're welcome to do that. But you're going to have to rearrange the whole matrix if that's what you do. Can you do a favor for your dyslexic teacher and not do that? That'd be great. Thanks. Because then I got to go figure out if what you did is right. In which case, I'll probably count you wrong. No. So 0x's, 7y, -6z, -3w, and a 7 solution. Just be careful. That's all. Think you can handle that one? I know you can handle that one. All right. So, moving along then. Here, I want you to take a system of equations, and I want you to write it specifically as a matrix multiplication equation. So, this matrix is going to be all of the coefficients for the body of your system. This matrix is going to be your variable matrix, and then after the equal sign would be your solutions. So all the coefficients from the body, they're all in the right order. They're not trying to be sneaky here. So we got a 3, 3, 3, 4, 2, -6, 4, and then a 4, 2, -4. Now this I do have to be kind of picky about. The variables in the variable matrix have to go in the exact order that they show up in your system. So x, y, and z is the order that, unless you rearranged it, that's the order you should keep with. And then the solution, same thing, they have to go in the exact order. So 38 and 8. Now, as far as how you're going to solve this, you got two methods. You could either type this guy in as matrix A and this guy in as matrix B, and you could undo the matrix by using an inverse matrix. So that would be A inverse times B is how you have to type that one in. Because technically what you're doing is you're applying the inverse of A to both sides of the equation in front of the existing matrices. Or you could go rogue and do the RREF thing. Yes, guy. You just use the inverse key, the x to the -1 key. So you see it? Okay. So me personally, I hate A inverse B. I think it's my dyslexia because I often do things backwards. So I like RREF. It's my favorite. So what I do, because this is a separate skill from what I actually type in my calculator, obviously, I'm never going to know which method you chose to solve this. So if you just love RREF so much you can't stand it, then just keep doing it. You don't have to show me that you did this on the calculator. I mean, there's no harm in you showing me if you feel like you may have done something wrong. And what some of us have found as we have worked through our homework and maybe got some questions answered, usually it's a case of something is mistyped. Like I was supposed to write down a -4 and I just wrote down 4, or I missed a 0 in my data value. So your choice how you get the answer. I want everybody typing something, and you should get the solution, the order triple 4, 2, 3. We've worked really hard to make sure that these come out nicely on your test. So if you do all this work and you get some crazy numbers, something's mistyped. You need to go back and figure that out. Anyone having tech difficulties? Not at the moment. So you do, regardless of your method of solving, you are going to be asked to separate it into a matrix equation. Okay? 423? You got 432? Oh, okay. Good. You were really messing with me for a minute. Anybody having tech issues? Need some old lady eyes to look at what you typed? Man. All right, so... You didn't get that answer? Did you use the RREF method? Okay. So can you open up that matrix in the edit menu for me? And then can you just double check that everything's typed right? So you got 3, 3, 4, 30, 2, negative 6, 4, 8, and 4, 2, negative 4, 8. Yeah? Oh, no. Okay. I was going to say, if it's typed right and you still didn't get the right answer, now I'm perplexed. All right. So, and that's usually the way it goes, Taylor. So, I mean, just you knowing that it was supposed to be a nice answer and you didn't get one would make you go back and double check your typing. All right, this next question is a good one. You're going to interpret someone already did all the calculator work. You're going to interpret the solutions from row reduced echelon form. So, I keep calling these X, Y, and Z for the 3x4s, but you can technically call them whatever you want. You're going to write your answers as ordered triples when it's appropriate. So this one says, for me, X equals 9. This one says Y equals 7. And this one says 0 equals negative 5. And then Adam tells me no. What does that mean? There's no solution, guys. 0 does not equal negative 5. You can't have coefficients of 0 coming out to an answer of negative 5. So then I look at the next problem where I think we do have a distinct ordered triple solution. We get X equals 12. And again, I call them X, Y, and Z, but you can call them whatever you want. Y equals negative 3. And Z equals 5. So ordered triple, this should end up in the same order regardless of your variable choice. 12, comma, negative 3, comma, 5. And then the next one is the fun one. This is where you have a statement at the bottom that is super not helpful. 0 equals 0, but it is true. So it's not that we don't have solutions, we just have so many solutions we can't find a unique solution. So what you guys have to do for me is set up a little algebra and translate this row for me. So we have, I'm going to use X, Y, and Z again. So 1x plus 3z equals 8. And then this equation right here would say 1y plus 2z equals 4. And then this statement down here just proves to me that z doesn't have any sort of a clue, I guess, about it. So we're just going to let z be z. So when you write your ordered triple, go ahead and just call z a z. But you should be able to give me some algebraic representation for x and for y in terms of z. Yes, so Adam did a little rearrangement here. He said I could just subtract the 3z over. And what did you call that? Love it. If you wrote down 8 minus 3z, you are also correct. And then for y, same idea. Oh, I crossed off. Was that a plus thing? Okay, so you would subtract the 2z over. So I'm guessing Adam's going to tell me negative 2z plus 4. But if you wrote 4 minus 2z, you are absolutely correct. And then, like we said, z is just going to be the variable z. So what we have here is an ordered triple that is in terms of z. So if I wanted to create a series of solutions that work for this, I would just pick my favorite number for z, I'd plug it in, and I get one particular solution that works. And then my neighbor could pick a different number for z, and they'd get a different solution that works. There's just a lot of solutions. There's infinitely many solutions. So I can't give a distinct one is the issue. So you will definitely see that question again. This is what we learned yesterday, and I know you're like, we just learned this yesterday, but I think this will probably be one of the most successful sections ever in PreCalc for you, because we've written it in a way where we're asking you to do very distinct things. So we saw yesterday those questions were really loaded. Like on your homework, if it was just like a find the maximum question and they didn't give you anything, like you had to do a lot of work. So what we did on the test was we separated the skills. So like for instance on this first one, we gave you a feasible region, we gave you the vertices, we gave you the profit function. I want you to find the maximum profit. So, okay. You need to take your profit function, your objective function, and you need to plug in all of your vertices into that function. Now, apologies if anyone looked at the answer key ahead of time. I had a mistake on it. Surprise. And it happened here, but I fixed it, and I'm going to repost it today. So plugging in, like 0, 0 is stupid, that's 0. 0, 8, if we plug it into this function, we get an 80. 4, 5, let's see, that would be a 16 plus 50, so 66. And then if we plug in a 6, 0, that gives me a 24. And we're plugging them into x and y into this profit function. So this was, first mistake I had was I called this 65. Second mistake I had, I thought 65 was the biggest number in this list. Wrong, Abruzzo. Who's the biggest number? Yeah, that guy right there. So you have a maximum profit of $80, and it occurs at 0.8. It was not my best moment, guys. Let me tell you. So the next question, we're going to ask you to do a different skill from this section. Can you create that feasible region if I give you a set of constraints? And I think the answer is yes. So you guys are very beautiful graphers. Me, not so much. So I'm going to show you what happens when you graph like Abruzzo. So first of all, x is greater than 0 and y is greater than 0 limits you to the first quadrant. The other lines, they're already in slope-intercept form, so that's incredibly nice. I need you guys to graph those. I'm going to concentrate while I graph mine. I actually made it. It doesn't really matter. It's about to go bad again. See, just ruined it. Okay, so we end up graphing a shaded region that's underneath all of these lines, but greater than 0 and for x's and for y's. So you guys end up with this weird little quadrilateral thing. And 3 out of these 4 vertices, I totally know what they are. This one, I'm not so sure about. Just because I can't graph. You guys might be really sure about it. So the ones that I do know, I know there's a vertex at 0, 0. I see that there's one at 8, 0. I see this guy's at 0, 6. Now, the place where the red and the green line intersect, if you can't see it because you didn't graph very carefully, hello me, you got to find algebraic solution to it. So I'm going to set them equal to each other. I'm going to say negative x plus 8 equals negative 1/2 x plus 6. And I'm just going to solve that equation. It's technically set up as a substitution question right now. So first thing, Abruzzo hates fractions, so she's going to multiply by a 2. She gets negative 2x plus 16 equals negative x plus 12. And then I'm going to solve. I'm going to add the x over, get negative x equals, I'm going to subtract the 12 and get negative 4. So apparently x equals 4. Y'all already knew this because you have an actual nice picture. And when I plug in the 4 to one of these statements, it doesn't matter which one, you get y equals 4 as well. Apparently this was the ordered pair 4, 4. Which you guys already knew. See, it pays to graph nicely. I mean, you can always use your calculator edge as a straight edge. Not everybody's writing on a tablet, you know. I don't even need you guys to do anything at that step. Can you graph? Can you find corners? That's all I'm asking on that question. And the answer is yes, I hope. And then we get the final question. Pigs and geese. You know it's going to be good when they start with pigs and geese. All I want from you on this question, guys, is can you set up the profit, the objective function, and can you give me the constraints? You don't even have to solve and find the answer. I just want you to set it up. Okay, so you see how all of these questions have been separate skills. Let's find out. All right, profit function. They did tell you that x represents the number of pigs and y represents the number of geese. So let's stick to that. That way your teacher doesn't have to think real hard. Go find the profit information in this story problem. It's usually at the end. Do you see it? $65 on a pig and $40 on a goose. So technically you guys should be naming your profit function something. I like to name them P of XY. You can call it F of XY. You can technically name it whatever. But $65 for a pig plus, what did I say, $40 for a goose. Oh, you gotta be difficult, huh? So the two obvious constraints, I went ahead and just told you. You can't have negative pigs and goose. That's weird. But there's some other constraints in here. He wants no more than 20 animals. So that right there, that's a constraint. If you add up his number of pigs and geese, it's got to be less than or equal to 20. So x plus y has to be less than or equal to 20. There's another constraint right after that that says he can have no more than 12 geese due to noise ordinance. So his number of geese, which is y, can't be above 12, so less than or equal to 12. And then the final clue is all about money. It says he spends $80 for a pig, $40 for a goose, and he only has $900. So $80 for a pig, $40 for a goose, and he has up to $900 to spend, so less than or equal to 900. And that's the end. Ooh. Now, there's some extra practice problems after this. Well, no, they're not going to make you do extra of these. Here's what our thought was, just from previous year's experience. This was a question where kids floundered a bit. Unfortunately, it's like just carelessness, dropping negatives, not distributing properly. So here's what I would say. If you never did this homework assignment with these questions on it, and it was like one of the first things in your homework assignment, I think it was worksheet 4 or something, 3, I don't know, way like before Thanksgiving. Just go do your homework, guys. That's enough extra practice for you at this stage in the game, okay? Just do your homework. On that, there's 2 problems we assigned. Just do them both. But here's some other examples. And I believe the first one took like a lot of work. And it doesn't matter if you solve for X or Y. Either way, it's a hot, hot mess. I think it might be easier if you solve for Y. Because I solved for X and it was extra messy. But it's up to you. I think those are good problems to practice because I feel like that is a place where kids just have an issue on the test. Unfortunately, it's not a conceptual issue. It's just a horrible, horrible, dramatic mistake of a negative or something horrible like that. Let's talk about what's going on for the calendar, guys. So you're taking your test tomorrow, obviously. Then, on Monday, we're going to review. So this is on, what date would that be? 12/9? We're going to review for the post part 1. Pause the video. So we're being real transparent with you guys as far as like what is on your test on Tuesday. So Monday we're reviewing, and then on Tuesday, 12/10, we are going to take post-test part 1.
Is post-start one multiple choice or short answer?
It's this. So this packet, guys, Mrs. Hoffbauer went through. She circled the questions that are from part 1, and she put Roman numeral 2s next to the parts that are from part 2. So like when I look at the first page of the review packet, number 4 is the only thing that you're going to see on Tuesday. But can you guys flip in this packet? Keep flipping, 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 flipping all the way to the back, and you'll see some awesome stuff on the back. What do you notice is on the back? Like the matrix test. Again. So let's call tomorrow your practice run, ace it, and then you'll feel really good about the back page of Tuesday's test because it's pretty much the same. Okay? Well, I'd rather you find out you failed it on Friday than on Tuesday because Tuesday is part of your final, right? So this is a big chunk of 20% of your grade. So keep that in mind. All right. So that's Monday, Tuesday. On Wednesday, 12/11, this is the day that we're going to review part 2. So on this packet, anything with a Roman numeral 2 next to it is on part 2 of the test. And you're going to take that on Thursday. Now, I'm a little undecided about Friday. It kind of depends on how tomorrow goes. So if you guys do awesome tomorrow, then that allows me to do some fun stuff with you on Friday and maybe do some in-class retakes and stuff. But if tomorrow goes poorly, it's going to be mandatory retakes. So do well tomorrow would be my suggestion for many, many reasons other than just your grade. The other issue on Friday, December 13th, this is the last day for retakes or makeups or anything. Okay? That's it, because the following week on Wednesday starts final exam schedule. Okay? So Monday, Tuesday, we're still reviewing there's another part to your final, guys. This is a big part of it. And then on final exam days, where you guys have those 80-minute periods, we have another test that covers all the topics that aren't on this test. Because why not? Okay? You're going to remember everything. It's going to be fine. You guys are honors. You know how to study for stuff. So that's kind of a rundown. Make sure you guys are keeping your eye on the schedule and also be aware of my schedule. Okay? I'm not after school on Tuesdays and Thursdays. I'm only after school on Monday, Wednesday, Friday. And before school, I have a couple meetings next week. So before school is not going to be great either. So keep that in mind, okay? All right, good luck.